All right, so most of you are starting to get the hang of identifying the number of significant digits in a value, identifying the estimated digit in the value, and then being able to round to either the appropriate place value or to the correct number of significant digits. So we are going to start moving on and looking at how we use that information in math. So today we're going to start with adding and subtracting with significant digits. You might get frustrated because some of the things that you learned when you were little are not how we approach problems today. So when we're adding and subtracting, there are a few things that you have to keep in mind, or a few things you have to look for. First, you have to check and make sure the units are the same. If they are not the same, you're going to have to do conversions before you do the actual problem. We'll learn about conversions at a later point in time. The other thing that you need to be aware of or figure out is which is the least precise of the measurements given. So that's where your overline bar comes in, and identifying your total number of significant digits comes in. So we're going to start with two simple addition problems. The first one is 343.71 meters plus 28.4 meters. So check number one is that they are both the same unit, and they are. So we don't need to worry about that piece of it. And then what we need to do now is figure out which is the least precise of the values. Okay. So the first one has 5 significant digits. They're all non-zero digits. And our last value, the 1, is our estimated value. The second number, the 28.4, the 4 is the estimated value again because they're all non-zeros, so we know that all of the digits are precise or are significant. So when we add and subtract, the rule is your answer is given to the precision of the least precise value. So our second value is only precise to the 10th place. So our answer, when we get it, will only be precise to the 10th place. So you bring down your unit because that doesn't change. So we're going to need to stop at this point with our adding. What you do is just like what we were doing yesterday and the day before. You look one number past and see if it affects this value here. It does not cause any rounding, so essentially it just does not matter. So then you go through and you do your adding. And your answer is 372.1 meters. Our second value, we again check your units. They're both grams, so we don't have to worry about conversions. And then you have to figure out what your precision is in your values. So in your first one, the 1, the 2, the 5, they all count. The 0, though, is not trapped. So it is not a significant digit. So our precision ends in the tens place. In our second value, the precision ends at the 9 or in the tenths place because they're all non-zero, which means our last significant digit and our answer will be there, but that doesn't mean that's where we stop our math, and I'll show you in a minute. So we only have to look one number past. The 6 is going to cause the 2 to round, and we're going to make that basically 830. Okay, so now we bring down the 0. Don't put a decimal because that would trap it, and then you just add your values. So the answer is 2,080 grams. So when you're adding or subtracting for that matter. Just because your precision ends in this spot doesn't mean your magnitude ends in that spot. So basically what we had to do with this one was round to the tens place. If you don't want to round in advance, you could go through and do your math like you learned in elementary school. So you would have 9, 6, 7, and then know that you have to round up. We have to stop there. And then you would have 20, 80 grams anyway. So you can round in advance or you could round after, but you have to make sure the precision is to the same spot as the least precise value. So 2 more problems here, another addition one. So if you look at this real quick, we know the precision is going to end there. We're going to cut that off. The 9 is going to cause this to round, so that's going to be 1, 0, and that's going to be 2. So 7. Our liters are the same, so we have that. So we have, what do we got? 3, 9, 2. So we have 293.7 liters there. Yes, all these digits were there. This measurement was very precise when it was taken, but this one was not, so it limits the precision of the answer. So now we have a subtraction problem. There's our guesstimated value. There's where our answer is going to end. The 4 does not cause rounding, so we can just ignore that. The meters were the same, so it's 5.312 meters. Okay, so now it is I would recommend that you stop the video at this point. You write these down or put them on a Google Doc, and then when you are done, please make sure you submit them for credit for class for today. If you have questions, please email me or send me a message through Classroom. Have a great day.